Okay, so I have another question. Okay, so here we are asked to find the Fourier transform of this signal. Okay, that signal is yt. Okay, it is a time domain signal, and it is equal to t square plus 29. Okay, so we are asked to find the Fourier transform of this signal, this time domain signal, and we can use this identity. Okay, here. So we are given a Fourier transform pair. Okay, yeah, I think you can remember that we have evaluated this. No, we have evaluated this e to the power minus a absolute t. Okay, and we get this kind of function. No, okay, we have evaluated this. Okay, so now it is given, so we can use this identity. Okay, we can use this Fourier transform pair to solve this. Okay, so we will see how to do it. So you can see now we are given this identity. No, we are given this identity. So as you can see, we can use the principal approach to evaluate this Fourier transform, evaluate the Fourier transform of this signal, that is yt e to the power minus j omega t dt minus infinity plus infinity. Okay, so you can substitute this term instead of this yt. Okay, and you can evaluate this integral. Okay, and you can apply the limits and you can find the answer. Okay, but as you could see, this integration is somewhat hard. No, it is difficult. So here we no need to go through this principal approach. Okay, and we can use this knowledge, we can use this data to solve this problem. Okay, so that is the first thing you should understand. Okay, that is the first thing you should understand. That is, we no need to go through this principal approach, Fourier transform pair approach, to find the Fourier transform of this signal. We can somehow use this identity to solve this question. Okay, so what is the first thing we should try to do? What is the first thing we should try to do? Can someone tell? What is the first thing we should try to do? So we are given this data. Okay, we are given this data. So first thing we should try to do to arrange this term, okay, with respect to this term. Okay, so so that is the first thing we should try to do. Okay, if you don't know the procedure, that is the first thing. So we are given a data, so we will see can we adopt this term with this term somehow. Okay, this term with this term somehow. That is the first thing we should try to do. Okay, so you know that. Okay, so you know that this expression, this term, we can write as, okay, so here you have omega terms, and here you have another constant. So this is a variable and this is a constant. Okay, so for this term also, we will try to differentiate the constant value and the variable value. Okay, that is the first thing we can do. Okay, so here you can see that here you have t square minus 10t. Okay, so this term you can write it in t terms, that is t minus 5 square. Okay, so these terms you can write like this. Okay, okay, so here you have t square, then minus 5 by t, that is 5t, and it should be multiplied by 2, then you will get minus 10t, and you have this 5 square 25, no, so 25 is there. Okay, and here you have 29, so here already 25 is there. If you add 4, you will get that terms, no, 29. Okay, so this term you can write in this way. Okay, I am sure that you have used these techniques in your O-level maths. Okay, to solve that equation. What is Vargaja Samikaran? I can't remember the terms. Okay, squared equation, Vargaja Samikaran. Okay, so I think you should use this in your elements. Okay, so this t square 10t plus 2 9, we can adopt it as t square 5 t minus 5 square. So we will get t square here, t by minus 5, that is minus 5t, and it should be multiplied by 2, then you will get 10t, and here you will get 25. Okay, so here the term is 29, so for these terms I'll add another 4. Okay, so like this term we can write in this way. Okay, so we can write it in this way. Okay, so here we have, now we have differentiate this omega. So these are variable and this is a constant term. Now we have differentiate constant term and variable terms separately. Okay, so now again we have to look how to solve this. Okay, so if you see this kind of signal, okay, what fact come to your mind? Okay. Can you remember any properties related to this term in Fourier transform? So you can see that this t minus 5, okay, t minus 5, this t is variable, okay, this t is variable. So if we get t minus 5 as capital T, okay, so this t, when you change in this t, and this capital T also changing in linearly, okay, only 5 shift is there. Okay, but when you are changing this t, this capital T also changing. If you are changing this minus infinity to plus infinity, this capital T is also changing from minus infinity to plus infinity. Okay, so so if you want, you can write this as like this. Okay, so like this you can write it. Okay, so anything can you remember when you see this kind of terms? Okay, here we have the Fourier transform. Okay, and we have a signal, but with here it is omega, but here it is t, time. So can you remember any property to apply? Actually, I like if you answer this kind of question, okay? Okay, so uh, in previous week also we have tried. We have used this. We have solved this type of question. Okay, uh, so the property you should use here is the duality property. Okay, I think now this kind of fact should come to your mind. Okay, when you see this, if you see this kind of pattern, this property, at least the fact that this kind of property can be used, that fact, at least that fact should come to your mind. Okay, so here we will use duality property. Okay, so duality property, I think you can remember the duality property. Okay, so here it is here it is stated that if we have, this is a duality property. Okay, if you have xt signal, okay, if you have a time domain signal, if you have time domain signal xt, okay, then the Fourier transform or inverse Fourier transform is x omega, capital X omega. This is a Fourier transform pair. Okay, so duality property said, okay, if you given this type of time domain function, okay, this type of time domain function, that is capital xt, okay, then you can directly find the Fourier transform of this signal xt using 25x minus omega. Okay, so this is the duality property now. So if you are given this signal, you no need to go through principal approach using that Fourier transform pair. You can directly get it. What you have to do, you have to substitute minus omega. You have to substitute minus omega instead of this t. Okay, and it should be multiplied by 25. Then you will get the Fourier transform of this xt. Okay, so here it is the same things, no? We have a function, time domain function, e minus a absolute value t. Okay, and we have 2a square omega square. Okay, so that is correct. No, this is t variable. This is xt. The independent variable is t, and this is capital X omega. This is capital X omega. Okay, so here the independent variable is omega. Okay, okay. So if you are given this type of frequency domain signal, sorry, time domain signal, that is, if you are given 2a square plus t square, not omega square. Okay, here it is omega square, here it is t square. If you are given this kind of function, you can directly get the Fourier transform as 25x minus omega. No, so here is the xt, and what we should do, instead of t, this t, we can substitute minus omega. Okay, so e to the minus a, e to the power minus a absolute, instead of t, I am substituting this omega. Okay, and that should be multiplied. This term should be multiplied by 2, 5. 2, 5. Okay, so this is the duality property now. This terms and this term is the duality property. Okay, so I don't want to go through principal approach to find the Fourier transform of this signal. Okay, I can simply use the duality property and find the Fourier transform easily. Okay, so here I have found it. Okay, so now you have this kind of function. No, now you have, okay, so what is your function? Yt is equal to 1 by t square 5 square 2 square. No, here you have 4. Here you have 4. So I can write it as 2 square. Okay. Here I can write it as 2 square. Okay. So I have write it as 2 square. Okay. So as I have explained, this t minus 5 we can represent with t, capital T. Then we will get 1 t square by 2 square. Okay. So I will get this kind of signal, no? So, but 2a should be there. Okay, so this is a, no, this is a. So 2a means 2 by 2. That is 2a. Okay, so now I have this kind of function, no? Okay, so I have 4 capital T square by 2 square. So I know that for this function, I can directly use this identity. Okay, I can directly use this identity, no? 2, 5 e minus, now a is 2, okay, minus omega, this identity. Okay, okay, but again there is a problem, no? Okay, but here it is not t, capital T. Okay, so this t is equal to t minus 5. Okay, so what is that? Okay, so so you have to go some further, no, to get the final answer, because this value is t by 5. Okay, so so what do you feel? I think some fact should come to your mind. Okay, so what you can see, so if we consider this yt is equal to 1 by t minus 5 square by 2 square. So what is this part? Okay, so what is this part? So if you say, if you have xt signal, xt is equal to 1 by t square 2 square. Okay, then if I get the time shifted signal with 5 second or millisecond, some time unit, okay, that is t by 5. Okay, then I will get t is a minus 5. So this is the yt, no? Okay. So if we have xt, this kind of signal, okay, if we have this kind of signal, okay, if we have this kind of signal, this yt is the time shifted version of this signal, no? This yt is the time shifted signal of this xt. Okay, here it is the time shifted signal, time shifted by 5 second, millisecond or something with time unit. Okay. Okay. So if you have minus t square capital, now I will replace this capital T by simple t square. So you will get this signal. Okay. Okay. But you have the time shifted signal, no? But you have the time shifted signal. Okay, then what property you should use? What is the property you should do? You should use you should use at this time. Please tell. Okay. So I think you know the answer. Okay. So here it is the time shifted signal. So time shifting property we have to use. No, that is very simple. Okay. Here you have the time shifted signal. Okay. Here you have the time shifted signal. Then definitely time shifting property you have to use. So so you have the signal for t square by 2 square. You have the answer that is 2 5 e minus 2 minus omega. Okay, so you have this identity. Okay, so this is if this is xt. Okay, this is the x omega. Okay, if this is xt, this is the x omega. Okay, so you have a time shifted signal that is yt. Okay, yt is the, if we get this signal as xt, that is the time shifted signal by 5. Okay, so you will get t square 5 square plus 2 square. Okay, but here you have 4. Okay, here you have 4, and to balance this you can divide this by 4. Okay, so you have this signal. Okay, you know the Fourier transform of the original signal. Okay, and if you know that original signal, you can find the Fourier transform of this time shifted signal using time shifting property. That is, if xt minus t naught, okay, you will get t to the power minus j omega t naught capital X omega. Okay, so you can use this property, time shifting property. Okay, here the time is shifting by 5. Okay, so here you have xt, that is 2 5 e to the power minus 2 absolute value minus omega. Okay, so here it is a time shifted signal, but it is divided by 4 to balance this 4, because original function doesn't have this one. Original function have 1 here. Okay, so here it is 1 1 5. Okay, and e to the power minus j omega t naught is 5. No, t naught is plus 5, j omega 5, and x omega is e to the power minus 2 minus absolute. Okay, so here minus absolute means you can get the minus absolute again, you will get the plus value. So you can remove this minus term. No? You can just write, I will write it here. So you can just write the Fourier transform of yt, okay, as 1 by 4 e to the power minus j omega 5, okay, e to the power minus 2 absolute value omega, like this. So this is the answer. So first you have to uh, adopt the given signal. Okay, given signal, or you have to tally the given signal with this term. Sorry, with this term. Okay, with this term. Okay, you have to tally the signal with that term, or adopt the signal with that term. Okay, then you have to use the duality property. Duality property. Okay, then you have to use the time shifting property. Time shifting property. Okay, so here you have used two property to find the Fourier transform. Okay, so I hope so I think we don't have much time, because at 3 o'clock you have a lecture, as I know. So we will wind up. I have another example, but we don't have time to do. Okay, I will record it and upload that example. So we will wind up, but please hold on for a minute. Okay.